Hi, today we're going to the PAT paper from 2008 looking at question 9. Okay, so question 9 tells us that a die is biased, that a 5 and a 6 occur 3 times more often than a 2, 3 or 4, and number 1 is never obtained. We're asked to find the probability that a 2 is thrown, and when 2 consecutive throws are made, their total is greater than or equal to 10. So let's start with I. Well, how can we begin this? Well, we know from definition that the sum of all the outcomes must be equal to 1. So what we could do is, well, we know there's 5 possible numbers I can show up, because 1 can't show up, so we can get a 5, a 6, a 2, a 3 or a 4. And we know the probability of 2, 3 or 4 is the same, and the probability of a 5 and a 6 is the same. So let's just say that the probability of a 2 is equal to some number x out of the number of possible outcomes, x over 5. So the same way as if you did a normal die, you'd do 1 over 6, because if it was a fair die, you have one number out of 6 options. We know it's not fair. There's 5 options, but we don't know what weighting it is, so it's x over 5. So that means that probability of a 2, x over 5, plus probability of a 3, plus probability of a 4. Sorry, this shouldn't be. That should be over 5. Plus probability of 5, well, that's 3 times the probability of any of the 2, 3 or 4. So that's 3x over 5, plus the probability of a 6. That's again 3 times the probability of the other ones, 3x over 5. That should be equal to 1, the total number of outcomes, the total probability. Okay, so adding up and multiplying by 5, we get 9x is equal to 5, and therefore x is equal to 5 over 9. And therefore we see the probability of a 2 is equal to x over 5, 5 over 9 over 5, which is 1/9. And we notice this is actually the same as having a 9-sided die. And that makes sense because we have, if you imagine a 9-sided die with 3 sides 5, 3 sides 6, and the other 3 sides being 2, 3, and 4, then clearly the probability of a 5 or a 6 will be 3/9, and then 1/9, 1/9, 1/9. So it's 3 times more likely to show up. So that makes sense. So about part II. Okay, so what's the probability we get? Well, how can we get a score greater than or equal to 10? So let's just do roll 1 and roll 2. So we have a 6 and a 6, that gives us a 12. We have a 6 and a 5, that gives us 11. We also have a 5 and a 6, so we have to do that twice. We could have a 6 and a 4, that would give us 10, but again we could have a 4 or a 6, that's twice. And we have a 5 and a 5. Any other combination we're using less than 10 so it doesn't count. So the probability of our score, S, being greater than or equal to 10, well, that's equal to the probability of rolling a 6 and a 6, plus twice the probability of a 6 and a 5, because the probability of a 6 and a 5 is the same as the probability of a 5 and a 6, plus twice the probability of a 6 and a 4, plus the probability of a 5 and a 5. So what's that equal to? Well, the probability of a 6 is 3/9, and the probability of another 6 is 3/9, so it's 3/9 times 3/9, plus 2 times, probability of a 6 is 3/9, probability of a 5 is 3/9, plus 2 times, well, probability of a 6 is 3/9, probability of a 4 is 1/9, plus probability of a 5 and a 5, well, that's 3/9 times 3/9. Okay, well, that's equal to 1 over 81 into 3 times 3 is 9, plus 2 times 3 times 3 is 18, plus 2 times 3 is 6, plus 3 times 3 is 9. 9 plus 9 is 18, 18 plus 18 is 36, 36 plus 6 is 42, so it's equal to 42 over 81, and that comes out to give us an answer of 14 over 27.